Module 6. Studies find that increased parental support for college results in lower grades. People with mental illnesses more likely to be smokers. What should we make such news headlines telling us that students whose parents pay the college bill tend to underachieve? The smoking is associated with mental illness. Do these correlations indicate that students would not achieve more if their parents became less supportive and stopped smoking could produce better mental health? No. Read on. So correlation. Describing behaviors is a first step towards predicting it. Naturalistic observation and surveys often show us that the one trait or behavior is related to another. In such cases, we say the two correlate. A statistical measure helps us figure out closely two things vary together, and thus how well either one predicts the other. Knowing how much aptitude test scores correlate with the school's success tells us how well the scores predict school's success. Throughout this book, we will often ask how strongly these two things relate. For example, how closely related are the personality scores of identical twins? How well do intelligence test scores predict career achievement? How closely is stress related to disease? In such cases, scatter plots can be very revealing. Each dot in a scatter plot represents the values of two variables. The three scatter plots illustrated the range possible correlations from a perfect positive to a perfect negative. A correlation is a positive if two sets of scores such as height and weight tend to rise or fall together. Saying that the correlation is negative says nothing about its strength or weaknesses. A correlation is negative if two sets relate inversely, one set going up as the other goes down. The study of Nevada University students' inner speech discussed in Module 5 also included the correlation component. Students report of inner speech correlation negatively with their scores on measures psychological distress. Those who reported more inner speech tended to report slightly less psychological distress. Statistics can help us see when the naked eye sometimes misses. To demonstrate this for yourself, try an imaginary project, wondering if tall men are more or less easygoing. You collect two sets of scores, men's heights and men's temperaments. You measure the heights of 20 men, and you have someone else independently assess their temperaments. With all the relevant data right in front of you, you can tell whether the correlation between height and reactive temperament is positive, negative, or close to zero. Comparing the columns in Table 6.1, most people detect very little relationship between height and temperament. In fact, the correlation is imaginary. Example is positive, 0.63. As well, we can see if the display in the data is a scatter plot in Figure 6.2. On the next page, moving from the left to right, on the upward oval-shaped slope of the cluster of points that shows our two imaginary sets of scores, height and temperament, tend to rise together. If we fail to see this relationship when data are presented in systematically as in Table 6.1, how much less are we likely to notice them in everyday life? To see what is right in front of us, we sometimes need statistical illumination. We can easily see evidence of gender discrimination when given statistically summarized information about job level, seniority, and performance, gender, and salary. But we often see no discrimination when the same information dribbles in case by case. See Table 6.2 to test your understanding further. To point, remember, correlation coefficient can range from -1 to +1. reveals that the extent to which these things relate to the closer score gets to -1 or +1, the stronger the correlation. Correlation and causation. Correlations help us predict. The New York Times report says that U.S. counties with high gun ownership rates tend to have higher murder rates. Gun ownership predicts homicide. What might explain this guns-homicide correlation? I can almost hear someone thinking, well, of course, guns kill people, often moments of passion. If so, that could be an example of A, guns causes B, murder. But I can hear others readers saying, not so fast. Maybe people in dangerous places buy more guns for self-protection. Maybe B causes A. Or maybe some third variable C causes both A and B. Another example, self-esteem correlates negatively with depression. So does low self-esteem cause depression? If based on correlation of evidence, you assume that it does. You have much company. A nearly irresistible thinking error is assuming that association, sometimes presented as a correlation coefficient, proves causation. But no matter how strong the relationship is, it does not. As options 2 and 3 in figure 6.3 show, we get the same negative correlation between self-esteem and depression. If depression caused people to be down on themselves, or if some third variable, such as the heredity or brain chemistry, caused both low self-esteem and depression. This point is so important, so basic to thinking smarter with psychology, that it merits one more example. A survey over 12,000 adolescents found that more teens feel loved by their parents, the less likely they are to behave in unhealthy ways, having early sex, smoking, abusing alcohol and drugs, exhibiting violence. Adults have power and effect on their children's behavior right through the high school years. Gush and Associated Press story reporting that the finding. But this correlation comes with no built-in cause-effect arrow. The AP could as well have reported well-behaved teens feel their parents' love and approval. Out-of-bond teens more often think their parents are disapproving jerks. The point to remember: association does not prove causation. Correlation indicates the possibility of cause-effect relationship, but does not prove such. Remember this principle, and you will be wiser as you read and hear news of scientific studies. In such studies, researchers can check a treatment's actual effects apart from participants and staffs believing in its healing powers. Just thinking that you're getting treatment can boost your spirits, relax your body, and revive your symptoms. This placebo effect is well documented in reducing pain, depression, and anxiety. And the more expensive the placebo, the more real it seems to us. A fake pill that costs $2.50 works better than one costing 10 cents. To know how effective a therapy really is, researchers must control for a possible placebo effect. Independent and dependent variables. Here is a practical experiment. In a not yet published study, Victor Bensassi and his colleagues gave college psychology students frequent in-class quizzes. Some items served merely as review. Students were given questions with answers. Other self-testing items required students to actively produce the answers. When tested weeks later on the final exam, students did far better on material on which they had been tested, rather than merely reviewed. By a wide margin, testing beats restudying. This simple experiment manipulated just one factor, the study procedure. We call this experimental factor the independent variable because we can vary it independently of other factors such as students' memories, intelligence, and age. These factors, which can potentially influence the results of experiment, are called confounding variables. Random assignment controls for possible confounding variables. Experiments examine the effect of one or more independent variables on some measurable behavior called dependent variable because it can be very depending on what takes place during the experiment. Both variables are given precise operational definitions which specify the procedures that manipulate the independent variable or measure the dependent variable. These definitions answer, "What do you mean?" the questions with a level of precision and enables others to repeat the study. Let's pause to check on your reading, check on your understanding using simple psychology experiment to test the effect of perceived ethnicity on the availability of rental hours. Researchers sent identically worded email inquiries to 1115 Los Angeles area landlords. So 1,115 Los Angeles area landlords. These researchers varied the ethnic connotation of the sender's name and tracked the percentage of positive replies. Patrick Douglas said Ala Rahman and Charles Jackson received respectively 89%, 66%, and 56% invitations. A key goal of experimental design is validity, which means the experiment will test what it's supposed to test. In rental housing experiments, we might ask, did the email inquiries test the effect of perceived ethnicity? Did the landlord's response actually vary with the ethnicity of the name? Experiments can also help us evaluate social problems. Do early childhood education programs boost improvised children's chances for success? What are the effects of different anti-smoking campaigns? Do school education programs reduce teen? And to answer such questions, we can experiment if intervention is welcome, but resources are scarce. We could use a lottery to randomly assign some people to experience the new programs and to control condition. If later two groups differ, the intervention effect will be supported. Let's recap. A variable is anything that can vary. Experiments aim to manipulate an independent variable, measure the dependent variable, and allow random assignment to control all other variables. An experiment has to at least have two conditions: an experimental condition and a comparison or a controlled condition. Random assignment works to equate the groups before any treatment effect occurs. In this way, an experiment test works to equate the groups before the treatment effects occur. In this way, an experiment tests the effect of at least one independent variable on at least one dependent variable, compares to the features of psychology's research methods.